Hello, students, and welcome to another screencast with Mr. Swan. Another screencast, but maybe almost the last one, as we're kind of wrapping up our end of the year. So what we're going to do today, I'm going to finish up the notes, and we'll do a little bit of page 8 and 9 of the reference table, and we'll take a look about some life's evolution on Earth. We'll do a couple slides about fossils, just a little bit of a refresh, and then I have a little video for you guys to go watch. And so picture of the day. So not really the most positive picture of the day, but one that we should know about regardless. A massive diesel leak that was actually occurred over in Russia, over near the Arctic Circle. So 2 European satellites have spotted an oil spill in the Arctic Circle. About 20,000 tons of diesel oil has leaked into the river in the Arctic Circle after a fuel tank at a power plant near the Siberian city of Norilsk collapsed last Friday on May 29th. The Russian Investigative Committee has launched an investigation into the incident, as the plant reportedly waited for about 2 days before informing Moscow authorities about the spill. As you can see in the animation, the oil depicted in red traveled down the river on May 31st and June 1st. The river flows into Lake, I think this is how you pronounce it, Piceno, which feeds into the Picena River. Watching from space, the European Space Agency's Copernicus Sentinel-2 mission has observed the spill, for which Russia has declared a state of emergency. The spill has contaminated a large swath of land that covers about 135 square miles. It is believed that ground subsidence, so that's when the ground actually starts to sink, or sinking and settling the ground beneath the storage tanks that was holding the fuel. So you had these like tanks that were holding the fuel, the ground below started to like sink/sag, and then they kind of just toppled over. Was pretty much the cause of the event. So this is going to happen more because the permafrost up in the Arctic is starting to melt and starting to thaw. So once that water goes away, water has a lot of volume to it, and that means that the ground can actually go a little bit lower. So I don't say this would be more of a common occurrence, but this is something that we got to watch out for. And so this shows like some satellite images from the 23rd of May up to the May 31st, then also June 1st. You can actually kind of watch it like work its way down, and like from the ground, like over in this section, like working its way down the river as it goes over here. A same kind of idea, but just from a different angle from the picture is the one down below. So the spill and eventually kind of working over into the lake that's over there. So that's something that we like to hear about a little bit. But it was kind of neat that you can actually see it from space, and a satellite is actually able to pick that on up, which then could maybe kind of work to be like, if people know it's happening, then they can kind of go work to maybe try to capture it, or at least some of it, or try to clean up some contamination. So let's move right on over to the notes. So this is really kind of coming down towards the end, and so if we were together, we would really have been doing quite a lot with these pages, but this is something that, since we're not there, I might as well just kind of show you what they are. And this kind of goes into life's evolution on Earth, and pretty much like how Earth became what we know it today. And this is like probably the topic. You can go as deep into this topic as you want. You can kind of know just like a little bit on the surface. If you find a part that really interested you can kind of go really deep into that part. Some people kind of like look into things that usually interest students the most, dinosaurs. So that's like a part that kind of comes on up during one of these kind of talks. Other ones, from like fish in the sea, like how they evolved, how things kind of got on land, and this picture tries to sum up at least a little bit of that. In the video, I'm going to show you, actually we'll do like a little bit more. So I figured I'll just kind of show you how to read it. So if you have your reference tables, please open up to page 8 and 9, and here's what we have. So we have this page. This is just page 8. Ton of stuff going on here, and so I'm just going to show you pretty much like what's going right on the left side. So this information, all the writing here, like all this part, my mouse is kind of covering like most of this box on this page, all happens and is being squeezed down into this tiny little section in this timeline. So right over here is a very long timeline from modern time, which is on the top, all the way to 4.6 billion years ago, which is the estimated time of formation for our planet. And so this kind of shows like the timeline. Most of this writing, again, it just happens on this tiny little spot right towards the most recent part. Before this, we have a time period called the Precambrian. And so that's the eon. The Precambrian is really broken up into the Archean and the Proterozoic. If those words sound familiar to you from biology class, like the bacteria or those like little tiny like organisms that are very, very small, that's where they actually got their name. That's where they actually evolved from. And it kind of gives you some of the major highlights, such as when the Earth actually formed, our oldest known rocks that we have actually currently found, evidence of biological carbon, earliest stromatolites, and I'll pull up a picture about them. I just have to go do it. And then oceanic oxygen, like how it actually got formed by cyanobacteria, one of my favorite types of bacteria. And I always kind of imagine like a time machine, like it just won't work out. Like first, if you were somehow to go back, you're like, I want to go back to the very, very beginning of the Earth. Like here, it'd probably be like all molten. And like then your time machine would sink like into the lava, and that would just be the end. If you went back over into here, you would be like, wow. You take like a deep breath, and you get out of your ship, and you take a deep breath in. You're like, there's no oxygen, and then you would then pass out and die. And so that just won't really work out. And so there had to be a couple things that kind of went in. Most of it, if you were to go back and somehow survive, which would be really difficult, you would see pretty much photosynthesis happening in like little bits of like plankton, probably somewhere in the ocean. And that happened for a long time, kind of filling up the environment with oxygen, which then eventually killed anything that couldn't handle oxygen. And there's this kind of like massive wipe off. And that kind of goes into from biology, natural selection, and how our world kind of worked on and continued on. And so, as you might notice, this part is tiny in the timeline. And this part, just like a couple things I just mentioned, are kind of it for the timeline of like almost 4 billion years. There's not really, honestly, too much more to say. You can try to go into it more and trying to get to like the, like maybe when this bacteria kind of formed. Do we have any fossils of them and things like that? And a lot of that answer is you don't really know, and we're just trying to rough out an estimate. And we don't really have any good. I shouldn't say that. We don't really have like a lot of information because the fossils are just not there anymore. We have some rocks, very, very old rocks, but very, very few. Most of them have been destroyed by weathering and erosion. So we don't really have like a lot of good information about what happened way back then. That's why this part of the chart is so blank. And it's just not filled up with stuff. And then this part of the chart, about the last 500 million years ago, we go into a thing called the Cambrian explosion. We kind of work for our eons down to what we call eras. Where we take this eon called the Phanerozoic, when this is what we call like the explosion of life, when the life got really complex, and it goes into Cenozoic, Mesozoic, and Paleozoic, and then from there we break those down into periods of time, and usually we give it like a late, early, or middle kind of nickname for like where things would kind of fall into that period about when something major on Earth happened in regards to life. So like before the Triassic, no mammals. And then after the Triassic, mammals. And so kind of going right on through them. The Burgess Shale is a famous rock outcrop because we can find a lot of fossils there. So that's pretty much how we kind of figure this out. So the Cambrian explosion is like when a lot of things started to form for some reason. And things got really complex. And there's all these crazy different types of life going all over the place. Most did not survive just from natural selection. And things kind of start to work on up. My favorite parts, and this kind of goes into like how deep into this do you want to go to, a normal lesson kind of going through like all this takes me like 2 hours of just like lecture time. So just going to get to this, my top 3 things I love the most. The Carboniferous, where if you go in anywhere else in the entire world, if you say the Mississippian or the Pennsylvanian, they probably won't know what you're talking about. But this is some famous rock outcrops that give us a lot of information about this. But the Carboniferous is a time period where we actually got all our like oil and coal down in the interior of the earth. And pretty much what happened is all before this, you had the first forests kind of starting to form and the first kind of like wooded plants, and they started to grow, and like areas that were swampy, they would kind of grow, they would live their life and sometimes die, they kind of fall over, maybe get trapped in that water, and there wasn't really anything to decompose them. Wind can do it, and water can kind of break things down, if it's near like the surface, but like actual like animal, there really wasn't anything to do it. And there really wasn't for like 50 or so million years. And they just built up, and they were like, the king of the plants is the trees, and they still are. They can grow the tallest. They're very like, they're hard. You can't really mess around with them too much, right? And so they fall, and they just stayed there. And they didn't decompose. And then eventually over time they would get buried in like that water, and they get like pushed down like into the ground, and then like more grow, and then this process then repeats. And you used to have like all this wood around, and eventually all that's all trapped carbon. It would get trapped under the ground, and then that's where we got our coal and oil from. After that, this is like when you start getting fungi started to form, and then that can decompose the wood faster than it can actually work its way down into the ground or get buried or anything like that. So most of it was buried in this time period. And then fungus now occurs. So like when a tree falls over and it kind of starts to rot, and if you were actually like, go walk out in the woods and you see like a tree that's been on the ground for like maybe like a year, and maybe you like push on it, like you kind of kick it or whatever, it kind of starts to crumble in your hands, right? it's because it's decomposing. You won't have time to be buried in the ground for that carbon to actually get pressurized, and with time actually change into that black coal or that black oil that we see. It just won't happen anymore. So all the coal and oil that we have, or really probably will ever have new, is there already in the ground, and more is not coming. And it just happened to be that little time period that happened over there. During this part, this is when you kind of get the reptiles start to form, and the reptiles start to kind of grow. And there were mammals too, like right around this time period of the Triassic. But really, it's all dinosaurs. When you kind of go the Triassic, Jurassic, and Cretaceous, it's all dinosaurs. Dinosaurs were the king of the planet at this time. Nothing was going to get rid of them. If you think about it, they're like a perfect kind of creature, right? That they're very fierce, really adept to survive. Some can survive cold climates, some can survive, in extreme warm water. They could actually go around for if you had like offspring, right? They would actually like lay eggs, and a whole bunch of them, and then they would eventually hatch. And pretty much like when a reptile hatches out of an egg, it's not like 100% good to go, but pretty much they can survive. Think of like a mammal, like a little baby. You can't just leave a baby alone like after it gets born and be like, all right, you're good to go. That just won't work out. You got even like 20 years of support where they become like a modern human, right? So mammals take like a little bit longer, and everything, like think about like the teeth and the claws they have. Some people talk about like if you get angry, or if you're like a little bit like lash out at somebody sometime, that's like the reptile part of your brain, and that's all they do, right? It's like fight, survive, food. That's just pretty much what they do. And then the only thing that really kind of helped us out, mammal-wise, is that ginormous meteor that came through and hit our planet. And it hit our planet at just the right time, at the worst possible time for the dinosaurs, where they actually talk about some things that are coming out over the actual lifespan and like amount of dinosaurs, and like just like any kind of animal that fluctuates. Sometimes there's a lot and sometimes there's a little. If you remember from biology, where you had like, you probably talked about, I'm guessing sooner or later, like wolves and like deer, right? If the deer population grows really big, then the wolf population can grow really big until maybe there's too many wolves and there's not enough deer. Then the both populations have to decrease, and then there's not a lot of wolves, so then maybe the deer population can start to decrease, and the wolves will actually catch up. And so it kind of goes like a roller coaster. And they think, this is one of the ones I just recently read, that meteorite hit at just the bottom part of one of those graphs for how many dinosaurs there were, and that just knocked the population even lower, and maybe too low to rebound from. So that really helped us out. So if that meteor didn't happen, dinosaurs would still probably be around today. They would probably be dominant. We wouldn't have evolved. Mammals do not really compete very well against a reptile. And if you think about it, how could they compete? After the meteorite happens, we had a lot of things going for us, right? Covered with fur, so it kind of holds in the warmth. Smaller, probably, den creatures. Omnivores, so you can eat not just meat, but like plants as well. So that works out really well for us. Lower amount of offspring, usually. And that offspring kind of clings onto the parent, right? So like, like the mother like has it like inside of her body, like as it's growing, right? And reproduce, and then it has like can be fed by milk for like a very long time. So all those things kind of help, like, your chances are your offspring is going to survive. There's only just like probably one of them, maybe two, depending on like the animal, but it's going to probably make it. There's always exceptions to all this. So that kind of like went on, eventually get into grasses, and then humans, where we are like right there. We're like pretty much that this black line is present day. We are just like a pixel or two right before it, right over there. So how long have humans been around? That's a great question. It depends on what you're kind of asking. Would you say, like, if you were to go back in time, like in your time machine, you went back like 10,000 years, you walked out and you saw like some humans around, and just by looking at them, you'd be like, yeah, they look like me. And they'd be like doing things whatever humans do. If you went back like 200,000 years, you would walk out and you'd be like, yeah, they look like just like a person walking down the street. We haven't really changed that much. If you went back like 1,000,000 years, you would be like, oh, that's human-ish, right? That's human-ish kind of looking. I can see it, like they look a little bit different, but pretty close. And so that's where we kind of go. So like talking about like humans as like the species, you're going back a couple million. If you're talking about like modern day, you're really talking like 200,000, maybe to 300,000 or so. And if you're talking like technologically advanced, you're talking like, I mean, if computer technologically advanced, you're talking like 50 years. You're talking about like machines, and then you're going to go a little bit further, but not too much. So this idea is like where you actually go find those. This like little part right here on the right side, this like black line, that shows what type of rocks in New York State that we would actually be able to find. So if you want to go find a dinosaur fossil, like a really, really good dinosaur fossil from the Jurassic, and you'd be like, okay, I'm looking for the earliest bird, right? And you went back over here, and you're not going to find it in New York State. You just can't. It's just at least not the surface. It's just not there anymore. There were a lot of things that happened during that time that you probably wouldn't see it. We were covered with oceans, actually, some of this, and it just wasn't going to happen. So that's okay. Where can you go? Southwest America actually has a higher chance of actually getting some stuff. South America, also a really good chance of finding some dinosaurs, but you don't find them in New York State. Do you want to find things from like way back, like the Devonian, Silurian, Ordovician, or Cambrian? Like probably a whole bunch of like crustacean-y shelled creatures. New York State is a good place to go because we have all that kind of stuff. So all the fossils that I was able to show you this year all came from New York State, and the thing they had in common was they pretty much were all shelly type creatures. Next one, distribution of fossils. Some that I really like, the trilobites and nautiloids. Some things have lasted, and this graph carries all the way over from the left side of the page all the way over to the right side of the page. So this is about 500 million years ago or so, that black line. So if you run to the next slide, so this one right here. So things that have made it, like corals. Corals have been around pretty much since our complex life began. They're still around. Gastropods, brachiopods, funny names maybe, but those are kind of the fossils, or actually shell creatures still alive, you'd go find on the beach. They really haven't changed almost at all since they pretty much were first formed. Two shells together, little animal on the inside, filter feeders, and it works out really well for them. This part has like kind of major events that would happen, like pretty much mostly in New York State. These things, this is the Alleghenian orogeny. That is a mountain building event. So like where these, we're talking about like the Adirondacks that happened more recently over here. But we're talking about like other ones like the Tectonics or the Arcadian Mountains. Those happen at different time spans actually through time. And then here kind of gives you an idea like where the continents actually were and how they've actually moved right around. So at one time, New York was like at the equator, which would be pretty cool. And then we have kind of shifted and moved up higher and higher all the way over into the northern mid-latitudes. So we've been moving around for at least for a little while. So this is like the jumping off point. It's like, do you want to know more? That's totally up to you now. You can kind of go into each one of these things, and some things will kind of surprise you. And some things surprise us. We have found fossils of bees, and we found fossils of flowers. And if you see like the Land Before Time movies, right? And they have like these flowers sometimes like showing like the way back early Earth. That's not true. Flowers are actually pretty recently made things back like about 100 or so million years ago. So you wouldn't really want to find them with like the first forest. They weren't there. They weren't there yet. Grass. Like modern day grass, even more recent than flowers, right? And some things that are pretty interesting is that we have found fossilized beehives that are older than any fossilized flower that we've ever found. And nobody really knows how that works. They're just like, so they were eating something. I wonder what they ate. And like, I don't know. That or maybe there's like, we just didn't get lucky enough to find these fossilized flowers that were even older, but no one's ever been able to do it. So just like some fun facts. And these things kind of go on all the time. Let's move on because I'm going to run out of time. Geologic clock, these are just different ways to visualize time. Sometimes people put it like into like a 12-hour clock and be like, well, if it's a 12-hour clock, the first humanoids, right? This is like when you go back like 2 million years ago and you'd be like, you look not really like a modern human, but like, yeah, I can see how it could kind of happen, That's what pretty much what that goes into. And so that goes into a certain amount of time. And so they would say like human existence, like 19 seconds. Modern humans, even lower than that. So like how much of like pretty much all the life that we know and love, how much has that really been around in the history of Earth? Very, very little. The past like 2 hours or so worth of time. Another one we call like the time spiral. I like the time spiral just because of the picture. but different people like this for different reasons. But this kind of goes from modern time would be the top part, and like then it kind of spirals back as you go back. And then some things to notice is like it kind of shows that where different things actually kind of hit in here, and you can see like different like animals kind of existing, right? Like a T-Rex, everybody's favorite thing. And you notice how it gets less detailed as it goes back. It's because our detail and our knowledge of that is less. Doesn't mean that there wasn't a lot going on. It just means that we just don't know what it was. So there's animals that have lived maybe millions and millions of years, died. Maybe the species has been eradicated, and there just aren't any fossils left for us to find. And so we will never know that they were actually there. There's lots of different fossils besides just the regular type you might see in a museum of like the bones, right? And those aren't really like, are those actual dinosaur bones? Well, no. Fossil means that you had the actual object and it's gone now. And what's been replaced with it is usually just minerals. And so I've never seen a dinosaur bone, and you haven't either. We've seen rocks in the shape of dinosaur bones. Just a little bit of a technicality there. Fossilized dinosaur eggs, like would you find, could they be rehatched? Like again, no, because they're all just minerals, but just in the shape of once they once were. That's there. We find dinosaur footprints, and this gives us a good idea of like what's happening for behavior, right? So, and how we actually kind of assume like okay, reptiles had long ago kind of these patches of eggs. Well, these ones do too. Do these dinosaurs travel together? Well, maybe you see multiple footprints. Are they pretty much lone hunters? Well, then maybe you just see one. And so like that's what we kind of use these tracks for. By the spacing apart of the footprint, by the depth, by the angle, you can tell if they're running or walking. You can tell their speed, which is everyone's favorite thing, which is math. And you can get a whole bunch of cool things from this. Petrified fossils, usually the bones, teeth, we find usually a hard thing. It doesn't have to be. It's possible that it's not, but those are even more and more rare. Mold fossils, usually when something kind of digs in. This is my little trilobite right here. And it digs like into the mud, and this one just happens to die. And really, we find one of these is really two fossils in one. Because it's a mold fossil and a cast fossil, right? So it died, and then it got eventually, all the rock around it hardened, and then the interior decomposes, and then it gets filled up with something else, and then that eventually hardens, and so you actually get the outline of the object, and then you actually get kind of the negative space, you could say, of the object. So that's what my last two pictures are for right here, and what that means is that's it. I don't really have any more. So this is my super quick nutshell version of some cool fossil and some cool history things. If you want to know more, well, that's what we're doing next. Here's the first video. This is like the history of the Earth in 5 minutes. This is like speeding through, and I like it because it has like some good animation, and it just talks about actually there's not really much talking really going into it, but like writing of kind of like what happens from the beginning, what we think versus like current time. Just kind of fun. The music's kind of nice. Some drawings as it kind of goes through the timeline. You'll notice some common trends of like there was a whole bunch of things and then they died. There was this time and then something hit it and then a lot of bad things happened. And that's just the history of the world that we live in and how it kind of moves on and changes over time. And then this one, this is by Kirk Johnson. Again, so this is a little bit different than his other video. This is just talking about like how is North America look and is the way that it is. Why are the Rocky Mountains over there? Why is a whole bunch of stuff kind of the way it is? And so no spoilers. It's a quicker episode. This is only 50 minutes versus the 2 hours what the other one was. And lots of good stuff. Very, very entertaining. The same thing as kind of before. He kind of goes around. You see him kind of talking about these things. And he's going to bring up, I watched this again with my wife. And he's going to bring up something you've never even heard before, and you're like, "What? For real?" And yeah, it's going to be for real. And so you'd be quite interested to see like, "Oh, that Rocky Mountains that we always seen, was it always there?" Like, no, it was gone. There is another one, and so it will be neat. I think you'll really enjoy it. No work for this. So this is my one of my last lesson gifts for you. I would say watch it and enjoy. There are other ones of this one as well. So this is a 3-episode series. It's called Making North America, and let me click the episodes. There we go. We're just doing this one, the Making North America, the Origins one. So the one I have linked for you. There are 2 other ones of like the life and human. So like how did the shape actually influence how humans came here, and kind of some interesting fun facts about that. Some other different ones are about in the life episode as well. So I think they're also worth it. But I'm only going to make you do just the one. So enjoy watching this one. If you really like it, give the other two a shot and try to learn something from it, which you probably will enjoy. So that's it for you. And I will see you on Wednesday for our last screencast together. All right. Have a good day, guys. Bye.